Here. So this session is about introducing ML.NET, which is kind of funny because we already introduced it yesterday. But my name is Ankit Astana, and I work on the VS and .NET team. And I'm actually joined here by
I'm Gallo, PM in the AI platform team.
So before we get started, we had a couple of poll questions for you. How many folks here have actually heard of ML.NET already in a session yesterday or something else? So pretty much our job here is done, Gal. We should do something else.
Yeah.
But so what we're going to get into this session about is getting more details and the architecture of the components and do some demos and so on. But before we go there, we have just one more question for you folks. How many folks here are .NET developers? Sorry for the show of hands. All of them? Perfect. This is what we like. And how many folks here are new to machine learning or are trying to get started with machine learning? Almost the entire room, or at least three-fourths of the room. Perfect. So this is the session for you. Perfect. So as .NET developers, we've kind of like .NET has been great for building a variety of things over the years. And you can build desktop apps, web apps, cloud apps, mobile apps, gaming apps, all kinds of apps there. And what this session is really about is how do we actually make .NET great for machine learning? And we're going to get into that. So Gao, for folks that are actually new in the room, how would you actually go describe machine learning?
Sure. So one way to do it is to say that machine learning is about programming the unprogrammable. If I ask you to write a function that takes in an image and tells us if there's a face in it, how would you start writing that? Or if I asked you to take the description of a shirt and, whoops.
Sorry, go for it.
And tell us what is the price based on the description of it, you might look for some keywords like exquisite or business setting, but it wouldn't necessarily work really well. And it's not clear how you would scale that up to other items. So even though we don't know how to write that function, well, we do have our examples of the inputs and outputs to that function. We have many, many images, and we can label those images to say whether they have a face in it or not. So machine learning lets us take that data, those examples of inputs and outputs, and create a model, which you can think of as a function that takes in the image as the input and tells you as an output whether there's a face in it or not. So there are many tasks in machine learning. Just to start with a few, classification is the one where if you're choosing between something, if something is A or B or C, that's classification. Regression is when you're trying to say how much or how many. If you're trying to predict the temperature tomorrow, that's a regression task. Clustering is a bit different in that there's no necessarily correct answer, but you have some data points and you're trying to group them into clusters where you have similar data points in one cluster.
So let's actually start with a very small demo here. As soon as I can figure out which machine this is like in 6, right? Perfect. And we're actually going to show you how .NET team itself, the engineering team itself, is actually starting to use machine learning and using ML.NET. So there are a couple of engineering leads here. Dan's here, Peter's here at the back as well. And we're going to show you one thing here is the .NET Core FX repo. So the .NET Core FX repo is, there's, as you can imagine, there's a variety of issues that come up there. And one of the things that we're thinking about is that how can actually machine learning help here, Dan and Peter in this case, to be able to do some of these tasks automatically. In this specific case, as folks file issues, can we do any tagging here to help them in terms of whether this is a .NET issue versus a .NET Web issue versus a .NET Socket issue and so on. So I'm actually going to demonstrate this next, and let's see what happens. So here's the Core FX repo. I've already kind of like filed in a title here. I've actually already filed in a description here. It goes into Clyde WebSocket and .NET Core. Yada, yada, yada. So I'm going to actually go ahead and submit this issue. So that issue gets filed. Now what we've done in the background is that we've actually built an app. It's a very simple console app that we've built. And what that does is that it actually pulls the GitHub issues on Core FX and brings them down and actually goes and labels them using a machine learning algorithm that we've actually written. So you can actually see here that in this case, it actually pulled in the issue that we have, which is 29583. It's actually added an area tag there. So let's see what that means there. So if we go back here, I'm actually going to make this bigger. Oops, made it too bigger. I'm actually going to go here. And we go down here. You'll see that there's a label tag here, areasystem.net. So that's kind of an example of what machine learning and ML.NET can do. Like this entire solution was written with .NET. How cool is that? You think, folks, that's cool? So what we're going to show you next is essentially a part of the series of demos that actually go about how we can build these kind of apps, but also about how machine learning can help in your everyday .NET app type scenarios. So we're going to get into how we actually build this issue classifier on GitHub. We're then going to get into a fictitious app that we built. It's called Smart Travels. It's very similar to Expedia. We've actually taken the pictures and everything else from there, too. You'll probably see it. And what we try to do with that app is that we actually try to book a flight, and we actually enhance it by adding flight delays. And we're going to show you how that's done using ML.NET. And lastly, there's a popular repo stories that Cesar here actually develops, and it's called eShop. I don't know how many people here know about eShop on containers, or have used it, or have heard of it. It's a popular .NET series of apps. And so what the last demo is going to demonstrate is going to be about forecasting capabilities that you can actually do with ML.NET. So we've taken a retail shop. There's a bunch of products in there. And we're going to use ML.NET to be able to forecast how these products will sell or behave during the year or the course of the year and so on. So those are the 3 examples that we're going to show you about how we're going to actually do this. But before we get there, we want to get into what ML.NET is. There's been a lot of, ML.NET's been covered in different sessions. But what this session is about is that we want to make sure that when you leave out of this room, you actually have an understanding of what ML.NET exactly is and what it exactly does. So ML.NET is really for building your own models or custom models. So what does that actually mean, right? So when you talk about, especially when you're talking to developer land, when you talk about machine learning, there's 2 kind of flavors of machine learning. You can use pre-built models. Like how many people here actually use cognitive services? Probably have heard of it. Most of the room here. Perfect. And with cognitive services, as you can imagine, it's actually really easy to get started. You go ahead, you create an Azure subscription, you activate cognitive, boom, you can start using cognitive services. In this example, for example, we're actually using sentiment analysis from the text analytics API, and we're trying to predict the sentiment on this is a gray vacuum cleaner. So as you can imagine, this is an obvious one that, hey, the sentiment is 96% positive. So that's great. So it's actually really good. Now, but what happens if we actually go and change the text on the sentiment analysis here? So what happens when we actually change the text here from being this is a gray vacuum cleaner to this vacuum cleaner sucks so much dirt? Anybody in the crowd wants to guess what happens there? Do you think cognitive or pre-train still apply? No? Some people are thumbs down. That's exactly what happens. So what happens is that with pre-trained solutions, a lot of them out there, what's going to happen is that they can't tell the sentiment here. The sentiment is going to predict is only 9% positive. So what do you do in such situations here? Because what's happened is that if you look at the reality of the sentiment, this is actually a great review for a vacuum cleaner. But how do you actually go about fixing this problem? So this is where custom or build your own really comes into play. What you want to be able to do is instead of actually training, instead of actually using a pre-trained model, you want to be able to use your data, teach the learning algorithm that this is good, this is bad, and then use that trained model then to do predictions. And that's really what build your own is about. And ML.NET is going to allow you to do that. Now, if you take a look at the solutions out there today, there's a lot of solutions out there for doing custom. Python and R are excellent choices if you're actually starting with doing custom machine learning. They have a great community, they have great docs, great libraries. And if you want to use Python and R, that's actually a great choice for you. Visual Studio Code provides a lot of tooling there for you getting started in Python today. Now, having said that, if you are .NET developers and you want to remain in the .NET stack and you want to enjoy the familiar experience from tooling and experience point of view that you have, you can actually use ML.NET, and ML.NET is for you. Does that make sense? Does that resonate with you? So moving forward, if you think about ML.NET, there's already a lot of products out there. Like there's, from Microsoft itself, there's Azure Machine Learning, and there's cognitive services. And the way we think about ML.NET really is that it actually complements these products. So when you think about ML.NET, it's about building your own models to give you that flexibility and control that you need for some scenarios. It gives you a code-first approach. And most importantly, it actually allows app local model deployment. And what does that actually mean? What that really means is that you can actually build a model, train it with your own data, and then it's essentially a zip file. You can actually take that asset file, check that into your app. You don't have to be connected to the network. You can use it behind a console app. You can use it behind a web API. It's really the flexibility that it gives you. So that's actually one of the other things that ML.NET does for you, that it actually allows your model deployment to be app local, and we make it really easy. We're going to demo that next. And a couple of other things I want to get across for ML.NET here as well is that ML.NET really is a framework first. And what do we mean by that? So when we started looking at the problem for machine learning in .NET, the first thing we realized is that a lot of the libraries out there, like CNTK or TensorFlow, have a lot of complex APIs for training and for model training and model consumption. And what we've done here is that the base ML.NET package essentially comes with the first component, which is developer-friendly APIs. So you'll be able to use these APIs for model training and consumption. So that's the first thing it gives you. The second thing it gives you is that a lot of times when you're doing machine learning, what's going to happen is that you're going to come in with some data that you have. But for you to be able to use the learning algorithms that are required, you need to actually use a lot of these transformations to transform your data into a shape that the learning algorithms can understand. And this is where the transformations come in. So ML.NET is going to give you a wide set of transformations that are fairly common and fairly complex that will really help you to build those transformations as you're actually going through building your learning pipeline. Second, any machine learning framework, this actually also comes with learners. It has state-of-the-art learners that we actually have, which actually do a lot of things. Gal, what are some of the things that these learners do today?
So we have linear learners. We have boosted decision trees. So you can do classification, regression, and some of the other tasks that we described earlier.
Cool. And what else does ML.NET come with? Does it come with something else as well?
So it enables you to do the full machine learning workflow. And we're going to talk about that in a bit in more detail soon. But it lets you load in the data efficiently. It lets you train your model, do all the transforms that Anke described, and then evaluate your model, deploy it, and so on.
That sounds great. And one of the other things, like, as the slide title says there, that this is actually a framework first. And what we really mean by that is that each of those boxes that you're seeing, transform, learners, and the miscellaneous package that you're seeing, they're all extensible, which means that they can all be extended. And what we're thinking of is that we want to work through this extensibility model and provide the ability to be able to use CNTK or TensorFlow or the leading library today in .NET, which is a card.NET, and other solutions that might come up in the future within that same umbrella of APIs that we've built for developer-focused machine learning. So that's really what this thing is about. Does that resonate with you? Does that make sense? Is there a couple of questions there in the room already about this? Anyone? No questions there? Makes perfect sense. Why are we doing this? What is this? OK, we'll keep going. And so one question you might ask is that Microsoft has a variety of libraries that we've shipped the last 2-3 years, or tools we've shipped in the AI space. So why does ML.NET matter, right? And so the history of ML.NET becomes really important here, because ML.NET has actually been used within Microsoft for more than about 10 years. It came out of research a decade ago. It's been productized internally. And now it's been used in perhaps most of the A-grade products that Microsoft ships. So it's used by a variety of products that are inside of Microsoft, and we're going to show what these products are. But more importantly, ML.NET was specifically written to support applications that were written in .NET. And it was specifically written to support .NET developers to be able to do machine learning. There's obviously some cases for data scientists there as well, but it's primarily written for those needs. And here are some of the products that actually use ML.NET. And even though you might have never heard of ML.NET by itself, what you're going to find is that you've already used a lot of these features that these different products provide that you're already using today, which are actually built and use ML.NET. So for example, Bing Ads actually uses ML.NET for when you're actually searching and you see the ads getting placed, it actually tries to select the right kind of ads that actually lead to a higher click yield and hence a higher revenue. Excel uses it for recommended charts, which is a popular feature that was added a few months back, I believe, or
it's in preview. I think.
It's in preview, yeah. PowerPoint, like how many of you have actually used design ideas? I certainly have used design ideas, and there's millions of slides that are being built by design ideas. Windows Defender uses it for malware protection, and there's a lot of other products that we haven't listed here. But essentially, the story here is that Microsoft really, a lot of the Microsoft products use ML.NET. And it starts from Windows, things like Windows Hello, to things like PowerPoint, and so on. And what we're trying to do here today is that we're trying to take the same goodness that we have within Microsoft for .NET developers, for .NET apps, and we're trying to externalize it as a part of the open source cross-platform repo that we shipped yesterday. So that's really what this is about. Now, the last thing we want to actually cover, or a couple of things that we want to cover here, is that as most things in .NET are today, ML.NET is cross-platform. It is open source. And you can actually go and play with it in our repo. We're going to go into there next. And someone might actually ask here is that, Ankit, you've been talking about how great ML.NET is. It's been used extensively within Microsoft. Why are you actually shipping 0.1 preview today or yesterday? Why is the team shipping the 0.1 preview yesterday? And the answer really is that, and we actually took one of these code snippets from the code here. We'd like you to read through that code snippet. ML.NET was really meant for internal Microsoft usage. It was never meant for external usage. So what you're going to find here is that there's actually a lot of things like that in the code that you can actually see. And what we're trying to do here is that this is actually the first time we're actually using externally. So what we've done is that we've taken the internal machine learning library. We've actually trying to build a high-level API on top of it that's developer-friendly, so that developers can actually use it. and in time, we'll bring the entire goodness of ML.NET that exists within Microsoft to external as well. But currently, we're shipping with the ML.NET 0.1, and what we're really looking for is your feedback, your scenario, so we can actually shape how this product should look like, and be able to, and for you to be able to use this in order to actually do machine learning in .NET. Does that make sense? Or are there any questions there in the room so far about what ML.NET is? That's the only primer we're going to give you today, and we're going to get into demos. So are there any questions there? Someone has a burning question right now that they want to ask? OK. So let's actually go and start looking at how you can actually get started with ML.NET. So it's actually really easy. If you actually go to our website, if you go to the .NET website right now, you can actually go to the machine learning page. You'll find a lot of options here for doing machine learning. One of them is ML.NET. You can explore ML.NET. You can click that link. You will see all the value props and stuff that ML.NET has. This will also take you to our GitHub repo, where you can actually file issues or look at the code there, what we're shipping today. You can actually get started through a simple experience here, like a command line app with the .NET CLI and so on. So that's kind of like, if you're looking for information about ML.NET today, that's one place to go. With that said, let's actually go ahead, Gal, and show them how we actually build the GitHub issue tagger with ML.NET.
All right. So the demo that Ankit showed earlier is an example of a classification problem. Because when an issue comes in, we're trying to identify which label this issue belongs to. So there are a couple of examples that we showed here that the .NET team uses. So this is an example issue in the GitHub repository. And we're going to look at the title and the description as our features. So feature is the input to a model when you're making predictions. It is the input to the function that we discussed earlier. It's what is available to us at the time of making the prediction. The thing that we're trying to predict is the label. In this case, it is the area-system.io in the bottom right of this GitHub issue. So we have a large collection of these issues in the repository, and we download them and provide them together to the learning algorithm to train a model. So we have the features and the labels. Once we've trained that model, we can just provide these features, the title and description of the issue, to get new predictions. So zooming out a bit into the overall ML workflow, the first step is to load the data. Once we have that data set, we need to transform it so that the learning algorithm can actually use it. In general, this means you want to turn everything into numbers, into numeric vectors. So we're going to show how to use ML.NET to do that on the text that we have in the GitHub issue. Once we've trained the model, we want to understand how good it is. That's the evaluation step. And if it's good enough, we're going to start using it in our app. So one concept I want to introduce is ML pipeline. So it's important to include all of the steps about how you prepare the data, and not just the model, when you think about bringing it to your prediction pipeline. So if you need to replicate those steps when you're making predictions, because the issue is going to come in, and you have to process the text in the title and description in the same way that you did during the training phase. And ML.NET makes it really easy to do that, to create learning pipelines. And you're going to be tired of hearing about learning pipelines by the end of this talk.
For the next hour, actually.
So we talked about the first stage being load the data. In this case, we have 16,000 issues from the core effects repository that are all labeled by the engineering leads. You'll see that we have the ID, the area, which is what we're trying to predict, the title, and the description. Now we're going to start the pipeline. So we create a new learning pipeline. We add a text loader that helps us read in the data set that we collected. So what we see here is the core effects issue class that we created that tells us the first column is the ID, the second is the area, and so on. And then we just tell the text loader to use that class and provide it the core effects _issues.tsv file. Once we start,
if I can ask you a question there, what do you think? How should we think about the learning pipeline? Is that like an API, or should we think about it like an API, or?
It is an API. So you start the learning pipeline, and then you add components to it as you go along. And at the end, we're going to train it and use that same pipeline, the model that it creates, to make predictions. So this is an example of the first row that we read from the data set. And we're going to see how the transformation steps that we add to the pipeline affect the data. So remember, we want to turn everything into numbers. So the first step is adding a dictionarizer. What this does is takes the area column and maps it to a number. And we're going to create a new column called label. So you'll see that area-system.net is now label 5. The next step is to add the text featureizer. This does all the work that you need to do to turn the title into a numeric vector that is meaningful for the learning algorithm. In this case, it's doing n-gram extraction behind the scenes. But it doesn't matter if you don't know what that means or how to make that work. You just add it, and we made sure that the defaults for the text featureizer are pretty good. We do the same thing for the description. And then we bring those two columns together into a features column at the end. So now you'll see, and you'll recognize from the previous slide, that we have label and features at the end there, and that's all that we need to train the model. So now we're ready to add the learner to our pipeline. In this case, we're adding stochastic dual coordinate ascent classifier, or SDCA for short. There are quite a few other learners in ML.NET that you can try, but we're going to use this one for this scenario. The last step, we're just going to convert the label that comes out of the model, which is going to be a number, back to a string that we can recognize on GitHub. Now that we've finished the pipeline, we can train it. So we bring in, again, the CoreFX issue class, which tells us how to read the input data, as well as a CoreFX prediction class, which tells us what is coming out of the model. So let's just quickly switch over to the code and step through it. OK. So I'm going to start running, and I have a breakpoint at the dictionarizer. So this is right after we've loaded the data. And what you can see in the debug window is that we have the pipeline object, and we can actually see several examples of the data that has been read in. So if you were following the slide that we showed earlier, you can actually see in Visual Studio how the transforms are affecting your data to make sure it's doing the right thing. So in this case, we've just loaded the data. And we have, so the way it's presented right now is going to be improved in the future. But right now, we just have the issue ID, the area, the title, and then the description. So as we step through this, we're going to, so first we're going to apply the dictionarizer, which adds the numeric label at the end. So now we have a 1 here. If I take another step forward, actually I'll take 2, both the text featureizers are being applied to the title and the description. So now you can see that instead of text, we've turned everything into numeric vectors. The last step of the transforms is to concatenate those two columns into one features vector. And now we're ready to start training. So I'll just let that continue while we switch back. So while that's training, after we've finished training the model, we want to understand whether it's actually good. When we deploy it to our production app, is it actually going to give us meaningful predictions on new GitHub issues? So the process for doing this is evaluation. We want to understand whether it's good on new data. So that's called generalization. One way to do that is to evaluate on test data. So this is data that you did not use when training the model. So what we actually did earlier is download all the 16,000 issues in the CoreFX repository and split them into 2 files, train with 13,000 issues and test with 3,000 issues. And the way we split it was based on the issue ID, so that the older issues were in the training data and the newer issues were in the test data. And the reason to do that is that you're training a model on historical data, and you're predicting the future. So it mimics the reality that if we trained a model today based on the data that we have, we're going to need it to predict well on data that is in the future. And the metric we're going to use is called microaccuracy. So that just means that out of all the samples in the test data, we're going to look at how many of them we predicted the correct label on. And this is the code to do it. So we again bring in the text loader. We give it the CoreFX issues test file. We create a classification evaluator and just provided the model and the test data. And it will give us the microaccuracy. So in this case, we're getting 73% accuracy in this model. Do you want to? Yeah.
Sorry.
So it finished running, and we got 73% accuracy, which is not bad. It's not fantastic either, but it's good enough to maybe get us started so that the engineering leads save some time and get a suggested label that they can then correct if needed. Yeah, let's switch back. So one thing that's interesting is that the accuracy across the different labels varies quite significantly. So for a few at the top, you see that area-system.net, the model is very good at predicting correctly. And that might be because there are some keywords in those issues that are easy for the model to detect. On the other hand, the meta area is very difficult for the model. Only 23% of the time it gets it correct. And that might be self-explanatory because the meta is kind of where everything else falls into. It's not something that's easy to detect. So we're pretty happy with our model. 73% is great. And now we're going to bring it into production. And the way we do that is as an issue comes in, we just do model.predict on that new issue. And then we have prediction.area to tell us what the appropriate label is. So one thing I want to emphasize is that machine learning is iterative. The first model is likely not going to be good enough. So we go back a few steps, and we think about what can we do to make things better. We might change the transforms that we're doing. We might change which learner we're using. Or we might even change which data we're bringing in. So in terms of this particular scenario, a few ideas for us are collecting a larger data set. So maybe in a few months, as there are more issues in the repository, we download the data set again and train the model. So in general, in machine learning, the more data you have, the better your model will be. Another approach is to think about the user profiles of who is submitting the issue. Some users might be submitting issues in very specific areas. So knowing who the user is might help us predict which area the issue belongs to. Another thing is that if the other .NET repositories use the same GitHub labels, we can bring in all of those repositories together and create a bigger data set and train a model on that. Other than bringing in other data, we can try and change the learning pipeline that we created. We might change the learner or the transforms or the hyperparameters, which are the things that you can tweak within the learner and the transforms to improve the model. So let's take a quick look at what we might do. So just to give a few examples, so we talked about how the defaults are pretty good. But what we might want to do, let me just close this, is, and I'm using a snippet here just to keep things fast, but there are for each of these transforms, there are parameters that you can introduce to change things and make things a bit better. So in this case, we might find that changing how many words in the n-gram sequence might make the model better. Alternatively, we might switch over from SCCA to something like logistic regressor, and that might improve our results, right? So we're going to experiment with different things to see what gives us the best accuracy. Let's switch back.
That's the next level, that's it.
Right.
Cool. So how many people actually think they're comfortable doing that, which Gal showed you in VS? Oh, wow. That's actually cool. That's actually a surprising number. So we're going to play a game now. It's called the pipelining games. And we're going to build a pipeline together. And this is kind of like a nice team event here that we're doing now. So we're going to play in this game is that here's a pipeline that we've come up with. And this is a pipeline for predicting taxi fares. So you take a taxi, we try to predict the taxi fare. The fare is depending upon certain variables like distance, time, the taxi vendor, and so on. So what we need your help with here is to be able to tell us what are the different steps that happen in the pipeline. And there's about 6 steps here, and the game here is to be able to get these 6 steps together and get them right. So who wants to go first? What's number 1 here? What's number 1 here? Sir, yes, sir.
You need the data.
You need the data. Perfect. We didn't even think of that slide, did we? So you're right. You need the data. That's absolutely right. So luckily, what happens is there's actually in public domain, there's actually a lot of data that's available that you can actually go to and grab. We're going to show you a few examples of this public domain data that you can actually use. And in this case, we're just going to assume that we've actually loaded the data or the data already exists. Great. So does someone else want to go through? And so what was the number 1 here? It's the first step here in being able to build this pipeline here. Someone in the crowd? Nobody here? Yes, sir. Declare the pipeline. Exactly. So that's the first step here. Thank you. So maybe someone on this side of the room now what should be the second step be in terms of building a pipeline? So you've already declared the pipeline at this point. Anyone here? Yes, sir, at the back. Sorry? Text loader. Perfect. Yes. So once you find your data that someone actually indicated that we didn't actually have here, you can actually declare a pipeline API. Once you've declared a pipeline API, the next step is actually to go ahead and add that data or load that data for the pipeline to be able to use later when you're building that learning pipeline. All right. So maybe in the back of the room there, what should be the step number 3 here? Once you've actually loaded the data and you actually already have created the pipeline. This one's a bit tricky. Anyone there? Anyone here? No? Nobody wants to take a guess? Call the vectorizer. Yes, sir. Somebody else? Sorry. Column concatenator. Anybody else? No? Features? OK, so column concat, features, and what was it? Vectorizer. So in this case, number 3 actually is, sorry, I gave away one answer. There's only 6 steps. That works well. So in this case, yeah, the number 3 is actually a vectorizer. So Gal, what is a vectorizer? What is this one hot vectorizer thing?
So in the same way that we discussed earlier about converting everything to numerics, in this case, we have categorical features. So it might be the type of taxi or like how the person paid. So that's a categorical feature. And we need to convert that to numbers. And the way we do that with categorical features, when there aren't too many of them, is create a vector of the length of the number of values it can take, which is all zeros, except for a 1 in the index corresponding to the string. In this case, let's say the taxi type.
Cool. So I think everybody should know what number 4 is, because I already let that slide. Does anybody want to have a shot at that one? Nobody? Sorry, say that again? Concatenator. Perfect. So once you've actually created your pipeline, loaded your data, done some transformations. I like saying that one hot code encoding, Gal. Is that what it is?
Hot encoding.
One hot code encoding. Then you actually go and you concatenate all these columns together to create a feature vector. And what you're doing with the feature vector here is that you're actually starting with data, and data could be string and floats. But we're actually getting to the feature vector. What you're really creating is a numeric vector that the learning algorithm actually understands. So that's the next step. What's the next step after that? So now at this point, you've basically created your feature vector. You've gone through a bunch of transformations. You've created your pipeline. There's only 2 more steps remaining. Anybody wants to take a guess? Sorry, say that again? Regressor, exactly. So then you actually want to go and add a learner. So once you've actually started, you've actually gone through creating the pipeline, loaded the data, gone through a bunch of transformation, created your feature vector, which is your numeric vector. You want to then actually go and add your learner, which is actually going to tell the trainer which learning algorithm to use to be able to train this model. And Gal, what does actually a tree regressor do?
It trains a boosted decision tree for a regression task. So you'll actually notice there's fast tree for several tasks in ML.NET, for regression, for classification, and so on.
Right. And then the last step here, once you've actually gone through all these steps, is actually to go ahead and train your model. And that's really how you're building a training pipeline. So it's actually not that hard. But it could be as you're getting started, there are some concepts here. There's a concept count involved here. And we're going to try to make it easier, especially for .NET developers, because that's what we're targeting here. But after this example, does everybody here feel that they feel comfortable now in being able to create a pipeline? Most of the folks here. So something else we're also building is actually a prototype for UI. So in Visual Studio, we like providing different kind of experiences for people who want the freedom to be able to do this. And what we're also aiming for is we have this prototype called ML Model Builder that we're working on right now. And what this will allow you to do is it will actually ease you into machine learning. It will actually teach you some of the concepts of machine learning that are there. It will actually allow you then to be able to see your data, see how different transformations actually change your data, be able to experiment by adding different learners and see which learner and which pipeline is actually performing better for you, so that you can actually create the best models, integrate that into your .NET apps. And what this UI also does is that it actually it auto-generates the training code that you just saw. So all the pipelining code that we're writing by hand right now, which is a code-first experience that we're going to provide, is also augmented with this UI, which is actually going to build that for you. So that actually makes things really easy if you're actually getting started with machine learning, and you want to get your hands wet and want to learn through the UI and explore the different facets of machine learning and so on. So this is something that we haven't launched yesterday, but we'll be launching this sometime this year. And if you want to try out a prototype, you can stop by our booth, and we'll be happy to show you that. Cool. So do you actually want to go through the learning pipeline in code as well, just so that folks can see some of the transformations there?
The taxi one?
Yeah.
Sure. So again, really simple. And it's exactly what you saw. So we bring in the data. We create the learning pipeline, the text loader that we showed. In this case, we have the taxi trip class, which tells us, which has a few more columns than the GitHub scenario that we showed. At the end, we have fare amount, which is the thing that we're trying to predict. And we're actually just reading it in as the label column immediately. So going back to this. So we do the categorical one-hot vectorizer on the categorical features, so the vendor ID that we mentioned, the rate code, and the payment type. And then we concatenate everything into features. So again, we'll have the features and the labels columns that we can provide to the learning algorithm. We add fast regressor, and then we train. And I started this just a few minutes ago while Ankit was talking. And we can actually see, first of all, the RMS, which is a metric that's used for regression. You want it to be as low as possible. In this case, it's pretty good. And we can see the predicted fare for a few examples. And the actual fare is actually really close. And you might expect that because the taxi fare is provided by, it's discovered by some algorithm that the taxi companies have created. But we've managed to find it through machine learning. So
cool. Sounds good. We'll go back to, is there any questions so far? We can probably take a couple of questions. Yes, sir, at the back of the room.
Once you have the model, how do you store it for users?
Perfect. We're going to get into that again, but let's show that in code.
yeah, we don't have it here. We'll do it in the
Right, in the next one. Sure. So the next example that we're going to show you is going to be about, so far we've actually shown you two examples here. And they've really been about ML tasks first. So we started with a GitHub example where we wanted to do classification of GitHub issues that were coming in into the core effects repo. The second example we actually showed you is a very simple example with the taxi fare prediction. We're again starting with a ML problem first. For the third scenario, we're actually going to start with an app first. So we're going to start with an ASP.NET Core app, which we built, which works sometimes. So we're actually going to go ahead and I'm going to show you this app. And this is, before I go there, I need to change my startup project. So let's go ahead and do that. Start this up. So this is basically a travel booking app that we built. And what it allows you to do is it allows you to book flights, right? So I'm actually going to go book a flight from Seattle to Las Vegas. I'm going to do some time traveling here. And I'm actually going to go back in time and travel yesterday. It's going to give me a bunch of search results here. So it's a very simple app. It gives you a bunch of search results. I can actually choose one of these flights. I want to get there nice and early, so I'm actually going to take the most expensive option right here. I'm going to provide a bunch of contact information. You can imagine that. Then I'm going to go with my credit card information and complete my booking. So that allows you to do like an end-to-end flight kind of like scenario where you actually go into your flight portal, search for a flight, and be able to provide some contact details and book it. That seems fair enough. That seems simple enough. So let's see what we can actually do with this app. So let's say that you are working in Smart Travels, and you're like, hey, I want to enhance the customer experience for my users. So what I want to be able to do is that when I actually search for these flights, I actually want to add some information about these flights. Maybe sentiment about, hey, this airline is great, this airline not so great. Or I want to add some information about whether this flight gets delayed, or this flight is on time, or this flight gives me a lot of great food, whatever. So in this case, what we're going to do is we're actually going to enhance this app by adding flight delay information. So where do we actually start for that, right? The first place that we start, as someone actually indicated earlier, is that you actually start with your data. So where can we find some data like this, Gal?
So in this case, there's a lot of data online available. I think it's in the Bureau of Transportation Statistics, in this case.
United States, sir? Yeah.
You want to go through?
Yeah, absolutely, yeah. So essentially, this data set is basically from the Bureau of Transportation. And what it allows you to do is it gives you data from all the way back to 1987, apparently. And it gives you a lot of different variables here in order to, this data set comes with about 108 features or data points here. So you can say year, you can say unique carrier, the origin of the air, which airline, destination, departure performance, and so on. So what we're going to do here is that we're actually going to take a data set. We're going to go back in time a little bit, 2017, and let's say September. And we're going to choose maybe 7 or 9 features that are the most influential features that we just came up with, right? So what do these features look like? Which ones do you think are important, Gal? Like year?
Probably year. Airline.
What about month? Day of the month?
The day of the week.
Yeah.
I think airline's pretty important.
Okay, airline, yes.
Origin, destination.
Origin, okay. So you'll actually go through, so in a real world experiment, what you're going to actually go through is you're going to take a look at data sets like these, and there's a lot of them available. You might actually have your own data in your company that you actually have from your customers, but even if you're trying to solve some problems that are common, there's a lot of data sets that are available in the public domain. And actually you can go through them and figure out which of the ones first perhaps make the most sense for the first cut that you're going to do. We already did that first cut for this scenario, and we actually came up with a bunch of data points here. So for this scenario, we actually came up with these 9 influential features: the airline, the origin airport, destination airport, scheduled departure, scheduled time, distance, month, day of the week. And these are some features that were the first cut that we saw, these 108 features. We're like, hey, let's pick the 8 ones that we think make more sense. And that's kind of like the first step of feature engineering that we did here. The next thing that we did, the next thing we're going to do is we're actually going to go and build this model for this particular app type. So if you look here, I already have a project here called Airlines Prediction. And, oh, I'm sorry. No wonder you couldn't see it. So here's my Visual Studio solution again. So here I have basically 2 projects here. One is the Airlines project. That's my ASP.NET project. And the second project here is about airline prediction. So this is my project where I'm actually going to build my model here. So I already have downloaded the same data set. So in this case, I downloaded a data set from September 17 to first month of January this year. And what I'm going to do is I'm actually going to predict flight delays for this month, essentially, right? So question for the folks in the room: what do you actually start with when you're trying to train your data? You start with data, but you're trying to train a model, sorry. What do you actually start with? You start with another time. We start with the learning pipeline here. So that's really the code here that you're going to see. That's the first piece here. So I'm actually going to go ahead and set a breakpoint here so you can actually see what's happening. And this is very similar to what you've already seen before. We're going to start with a pipeline. We're going to load the data. We're going to go and do a bunch of transformations. So let's take you on this journey with us. So for that, I'm going to change my startup project again. And I'm going to say start debugging. So what I'm going to do now is I'm actually going to step by one and show you how this works, right? So the first thing is, again, about creating a pipeline. You will go ahead and add the data that you have. In this case, that will be the data that we downloaded from the Bureau of Transportation website, and we cleaned it a little bit with the 9 features that we talked about. So as soon as I actually go ahead and jump to the next line, you can actually start seeing the data that's getting populated as a part of the rows here. So let me try to make this bigger. So you can actually see here, in the pipeline rows object, you can actually see all the data that's actually coming in as part from the CSV. This is just reading the data from the CSV. So I'm going to go and step into the next line now. And what the next line actually does is that it actually does a transformation called missing values row dropper. So does anybody have an idea what that means? Anyone who wants to take a guess? Sir, I'm hearing the right answer from somewhere. Perfect. Does anybody else want to challenge that? No? He said dump rows from missing rows from all the data. That's absolutely correct. That's exactly what this is doing. So what I'm going to do here is that I'm actually going to show you how this actually happens, right? So let's go one more time and open up Solution Explorer here and bring the data set. So what you're going to find here is that in this data set, what we're going to find here is that there are actually a bunch of rows that are actually missing data. So you see that when I actually search for comma, comma, in each of the rows, there is a missing value somewhere. So what happens is that the first transformation that we're doing in code there, the reason why we're doing it is because when you talk about learning algorithms, we want to drop the rows of data that actually don't have the entire data set. That's the first transformation we're doing. The next transformation that we're doing is essentially a one-hot code vectorizer. So what does that actually mean? A lot of your data here, like the airline name, for example, right? That's the string data. It's a categorical data type. And what we want to be able to do is take this categorical data type and convert that into a bit vector, which is what this is one-hot vectorizer is doing. So it's going to take your the way to think about one-hot vectorizer. Another way to think about it is that if you look at the number of airlines that are there, so let's say there are 10 airlines. So what you're going to do in one-hot vectorizer is that you're going to create a bit vector with 10 bits in there, and each bit is going to represent one airline. And in that bit vector, what's going to happen is that for each row, only one bit in that bit vector is going to be hot. That's really why it's called a one-hot bit vector. And we need to do that transformation because, again, a learning algorithm needs that one. So we actually do that transformation. And you're going to see that as soon as I actually did that transformation, everything in my debug locals window actually turned into a 1-bit vector. Do you see that? Like this is zeros and ones here. Let me make this bigger. You see that there? That's basically 1 hot bit vector right there as an example. So the last thing to do, as we saw in the pipelining game as well, is that once I'm actually going to go ahead now and create a feature vector, which actually takes all the different numeric features and groups them together to create a numeric feature vector, which then I can add a learner to and then start training. So that's really exactly what I'm doing. I'm going to add the feature vector, which is going to create that feature vector now. And I'm going to add the binary classifier learner, which is another tree learner that we have in ML.NET. And I'm actually going to start training this model now. So while it's training the model, let me actually show, someone actually asked in the back, how do you actually consume this model? So once the model has been trained, and we're actually happy with the performance of the model, what we can do is that the model object here has a function called write async. And what this allows you to do is it allows you to write the model to disk. So you can see where the model is going to get written at in this location. And then when I want to predict, what I want to be able to do is, I'm actually going to go and uncomment some code here. Some of the controls are not working, so I'll have to do this by hand now. Oh, thank you for teaching me Visual Studio. Thank you. So I'm going to wait for this to train now, and I'm going to talk. So the way you would look at this piece of code here is basically that in order to be able to predict now, what you need to be able to do is you want to be able to read the model using the read async method. Now we're back again in time. So now the training has been completed at this point, so I'll show you that later. So now when the training is complete, I'm going to write it to disk. I'm going to actually print this message, training and evaluating the model, because I'm feeling happy about it now. And the next step here is really to go and figure out whether this model is actually performing well or not. So as Gal mentioned this a couple of times, the basic practice in machine learning is that you basically train on a particular data set, and then you want to test your model on a different data set to be able to figure out whether the model is performing well or not. So that's exactly what we're doing here. In this case, we actually had 2 data sets that we downloaded from the Bureau of Transportation. We downloaded the data set from September to January this year for training, and now we're going to actually go and take the data set from February 2018 this year, and we're going to go evaluate the model. So let's actually go ahead and do that. So let's do that. OK, so it's going to now evaluate the model. And looking at the evaluation metrics now, so if you go back here, you can actually see the evaluation metrics in the debugger. You're going to find that this particular in this particular case, the model that we trained is actually not performing very well. It's only performing about 56%. Let me actually start to zoom in there. So you can actually see the accuracy of the model in this case is actually not very good, because it's about only 0.056. So that's not good. So what do we actually do to fix this model? Does anybody have any ideas what we can do in the room? Yes, sir.
So I was surprised that you put the scheduled departure
Yeah.
in as a one-hot vector actor. It seems like some sort of more continuous range that could be.
Would be more applicable. Gal, do you want to answer that?
Can you scroll up to the?
This one.
Further up. Yeah. So unless it's a time, can you go back to the data set?
It's actually
If it's a continuous time, you're right. It's probably not a categorical, unless it's split in some way so that you look at it like per hour basis. But it probably should be numeric.
Probably, yeah. We were trying out this model to split different time zones, different time periods in a day, and you'll see why we did it in a second as well, if you just give us a second. Thank you. So what we're going to do next here is that, so this model is not performing very well. So, but we're actually going to go ahead with this model and write it to we've already written this to disk, and we're going to go and start predicting on this model. And then we'll come back and try to fix this model. So let's do that, and I'll answer your question in the process as well. So I'm now again going to try to uncomment this code. There we go. And again, at this point, what this piece of code is doing is that I've just added a predict method here. And what that does is that it actually takes a flight data object, which we define, which is really the features that we came up with in a class, and then uses that to be able to read a model, to be able to read the model from disk, and then start doing predictions using the predict method here. So this var prediction is going to tell us whether the prediction was a flight delayed or not. That's really what's happening. Does that answer your question in the back of the room when you asked about how do you actually consume a model? So it's really easy. So the other choice that you get here with ML.NET here is that since you're writing the model on disk, and what you can actually do is you can actually deploy it in any way or shape or form that you like. So in this case, you can see that I go to my root folder in the data folder here, and my model file is actually sitting here. And it's actually written about at 2:01 p.m. So this is the model file that I've just trained. So that's how you will write the model to disk. And then if you want to read it, use the read async API that we're providing, and then you can start using it to predict different data predictions and so on. So the last piece here in this demo that I want to do is I want to go ahead and add this to my website so that we can actually start providing that delay service prediction in my app. So for doing that, what I'm going to do is I'm going to go back in the controller, and that's my controller right there. And I'm going to go into the search view. So this search method gets called every time we actually go and pick the origin location and destination location and say search. So this actually gets called then. So there's essentially a link query here that I've written, which is a very basic link query. It actually goes through and basically provides me the list of flights that it's come up with based upon the origin and the destination that I want to go to. So what I'm going to do here is I'm actually going to add another piece of loop here that's going to go and loop through the list, the different flights that have come up. And for every flight, I'm actually going to call the model predictor here. And that's going to tell me for each flight whether this flight is going to be delayed or not, or whether this flight is often delayed or not, right? So before I can show you that, all I need to do is enable that in my search menu. So I'm going to go to my search view here. I'm going to add another essentially column here. And that's going to help me predict flight times here, or flight delays in this case, right? So one last thing I have to do is change my startup project. So let me go ahead and do that. Let's hope this works. Warning, warning, warning. Oh, yes, somebody else. Very nice fuser as well. Thank you. Let's do this again. I was wondering why it's not coming up. So here we go again. So that's the same web app again. We're going to go ahead, provide Seattle to Las Vegas again, and we're going to be like search and provide me all the search results. So you would think that this demo is not working, but when I go down, you will see delays here being shown for different flight times and different flights here. So that what we've done essentially from the start again is that we've actually taken a public domain data set. We've taken our app, which is an existing ASP.NET app, used the public domain data set to build a model, all in .NET, and then we've basically deployed that model in localhost, catch, but deployed that model and then be able to now add that service to my app here. And that's actually telling me whether flights are often delayed or not. Now, there's another data science trend in here, if someone can actually catch that. It has to do with this column, which I have not formatted on obvious reasons to make this puzzle hard. But essentially, there's another puzzle here in terms of why are certain flights delayed. Anybody wants to take a guess in this room? Sorry, someone, anyone? I'm sorry? Some of them crosses days. Oh no. It's actually time, that one. It's not formatted very well. Oh, so yeah, so that's basically saying that flight goes from 7:25 to 9:46 a.m. Sorry, we made it worse a few minutes before the demo, but yeah. Always happens. So there's a trend here to do with time, actually. That's a real thing here. There's actually a trend here to do with time that certain flights are actually getting delayed after a certain time period. Does anybody else see that, or only I see that? People see that? OK. Someone in the backstory, yeah? Someone said something here. No? OK. So if you go back to this data set, this data set is actually a really good data set in terms of doing some explorations here. And what's happening here is that what you're seeing here in this data set is that if you actually pick the right cities, what it's going to tell you is that flights, like this picture here, this graph here that you're seeing here, this is basically the axis of time. This is flights arriving earlier or departing earlier before noon, and these are flights departing later afternoon. So that's actually some of the things you can find with data science, but you can actually find the same trends in this model as well. And that's why when you were looking at the search results earlier, in the web page, you're seeing that flights that are closer to noon or afternoon are actually going to be often delayed versus flights that are actually leaving or departing earlier in the day and so on. So that's the first trend. Now, there's another trend in this data set, which is the picture on the right. I'm not going to get into that one, but you have the slides. You can take a look at it. So yeah, what are some of the ways to answer the question that was asked here earlier to be able to improve this data and some of the stuff that we could do?
So similar to what we discussed earlier with the GitHub scenario, one way is to bring in more data. So if you look backwards in time longer and collect additional historical flight data, that might help you build a better model. However, at the same time, if you look too far back, it might not be as applicable to today's flights. So you have to balance that. The other is bring in different data. In this case, weather data might be helpful, and weather predictions might help you identify which flights might be delayed, because often weather can influence the flights. You can do other things in terms of cleaning the data. So Ankit showed how to remove rows that are missing data. Another approach is to handle those in some way, fill it in with mean values, average values, or something like that. So you keep them in the data set and still use them to train the model, because you're going to have missing data in production anyway when you're trying to make predictions. And that's something you need to be prepared for.
Right.
Yep.
Yeah, and to be honest, so for scheduled departure, one of the reasons why we were trying to create a category column there was we were trying to basically group them into categories: noon, before noon, early morning, dinner, after dinner, kind of like those different categories, and trying to figure out if the model actually operates better if you have those kind of categories there. That's why you were seeing that column there. If that makes any sense. No, OK. After the meeting, we'll talk. Yeah, sure. So the next demo that we have here is another existing ASP.NET app, and we're going to be doing sales forecasting there. So I'm actually going to give this to Gal. So Gal.
Sure. So this is the eShop containers demo that some of you are familiar with. And what it lets us do is search for a couple of products. In this case, we're going to search for a horse. It's not showing up. There we go.
Do you want to ask someone what they actually want for Christmas this year, Gal?
Sure. What do you want for Christmas?
That's a very nice question to ask. Yes.
So,
no, go ahead.
So in this case, we look at one item and we see the historical data about the sales, and what we're doing is predicting the next month of sales using that historical data. So we can actually go back to the code and see that it's exactly the same as what we've looked at so far. We create a learning pipeline. We have the text loader with product data. So if you're running a store, you might have historical data about how well each item sells and at what points of the year. And then we're doing the same things in terms of concatenating the columns that are numerical features, so they're all together. We are, we're dealing with the categoricals using the one-hot vectorizer, and then we are concatenating them before adding the fast tree Tweety regressor. So again, I mentioned ML.NET has quite a wide variety of learners. You sometimes want to experiment with them. And for this particular scenario, when evaluating on test data, we see that this one performs best. So that's what was chosen.
So how did you determine that? Was that trial and error?
How do you, yeah, so in this case, with machine learning, when choosing a learner or transforms or even the hyperparameters, there's some intuition that you build over time. So you might learn that, for example, we found that average perceptron works really well for text scenarios. But a lot of it is also experimentation. You're going to want to try out different things. And the important step is to make sure that your evaluation methodology is correct. Because otherwise, you're going to end up overfitting to your test data. You're going to find something that's working. You're going to find the thing that works best on the data that you're testing, but it's not going to work well in production.
Does that make sense? Sorry, there's another question here.
How often do you rebuild your models?
Excellent question, actually. Yeah, go ahead.
Yeah, so it depends on the scenario. So in this case, maybe we're getting data on a day-by-day basis. And you might want to retrain pretty often, because if you have the latest information about how the product sells, it informs how well it will sell in the future. In other scenarios, you might not need to retrain as much. And also depends on how much data you're getting kind of day by day, right? So with ads, for example, you might want to retrain. It's really important to retrain as quickly as possible or utilize the new data in some way. But in other situations like the taxi fare, where the algorithm to kind of calculate the fare is actually not changing day by day, you don't need to retrain the model.
Right. Any other questions here? Yes, sir.
Is there any sort of delta training, or is it like retrain?
That's actually a very good question as well.
So some learners have continued training. So you start with the existing weights of the model and bring in new data to update them. In other situations, you want to retrain completely.
Cool. we just have a couple of more slides, and then we can actually take more and more questions here. So, so this is really the start for ML.NET here. Like yesterday, we actually launched point 1, and point 1 does come with a lot of features that we're and more important than that, it actually comes with the APIs, the first draft of APIs that we've actually built for model training and model consumption. We really want your feedback there in terms of like how these APIs look like. Do they feel natural as .NET developers to you, using .NET for a number of years and so on. And then we're actually thinking a lot in the space of like, hey, what are some of the other scenarios that are common for developers that we can enable as a part of ML.NET? So we're thinking of things like, hey, recommendation models seems interesting. A lot of web apps probably have recommendation happening, so can we do something in that space? We're thinking of anomaly detection and a lot of other tasks that we can add there. If you remember at the start of the deck, we actually mentioned that the way we're thinking about ML.NET is that it's actually a framework first, which means that we're going to be working with TensorFlow and CNTK and Accord.NET to make them available via the same shareable uniform C# API for training and consumption. And that's something that we're thinking of. But what we really want in this list of things that we're working on, feedback on, is that what's actually stuff that you folks need in terms of scenarios, in terms of requirements, in terms of support for deep learning or other kind of things that you need for machine learning and AI. And that's the kind of stuff we're looking at. So the other tasks here are about supporting Onyx for WinML, ability to be able to do training in Azure. So right now when we were training on very small data sets. But in reality, if you want to build great models, you'll be training on a lot more data sets. You want to be able to experiment really fast. And you'll be able to do that with the abilities that we're going to add in this tooling. We're going to add a very nice Visual Studio experience on top of the Code First API so that folks that are coming in new to machine learning can actually ease into machine learning and learn about machine learning, but also be able to be more productive. And they're trying to say that test out 3 or 4 or 5 different pipelines with different learners and different trainers and all that kind of stuff. And the last thing is that we're not really ending here with saying that, hey, this is a framework and you're good to go. We're also thinking about language innovation in this space. One thing that I want to make sure that's actually understood here, or people have an understanding of as they leave, is that this is really a .NET framework, which means that we're working on .NET APIs here, which means that we're also thinking about it from an F# perspective, from a C# perspective, and so on. And that's something that we're going to be working on. But we're also adding new features and exploring and adding new features in C# to make machine learning easier. So we've actually, we've already been thinking about range. We're thinking about some other features in this space that actually make it easy for you to massage the data, to be able to easily express ML concepts easily in the language. So these are things that we're actually doing as well. Is there anything else that we should mention, Gal, here?
No, I think that covers it.
So essentially, that's pretty much what we came with, and we want to be able to leave about 10 minutes for questions and so on. But there's 2 great places to get started. If you want to get started with ML.NET, you can actually go to .NET ML. And there's a GitHub repo that we also have, which is the github.com/net/machine learning. We've actually had a great start there. We have close to 1,000 stars already. We're seeing a lot of action happening there. So please get involved. We really want to see your feedback in terms of how we can actually shape the future for ML.NET moving forward here. There's also another session. So there was a session before this where people were playing music with ML.NET and predicting and building music with ML.NET. That was Rowan Miller's session. The session at 4, Aditi at the back of the room and Bree somewhere here as well, they're doing another session about fun things and things that they can actually do with AI in general. So they have a really great demo about how to play music, which combines cognitive services, AML, ML.NET, all into one package demo that actually happens at 4 today, at Theater 1. So you should probably check that out after this talk as well. But with that said, we're really basically looking for any questions that you might have on ML.NET. We have about 10 minutes of time for that. Yes, sir, at the back of the room. Those will be available on GitHub by the end of the week, sir.
Some of them are already there.
Some of them are already there.
We're adding the rest.
Yeah. Anything else? Yes, sir.
Blob format from the ML.NET, is that documented format or is it proprietary to ML.NET?
You want to take that one? Proprietary.
It's for ML.NET, but it's all open source, right? So you can actually take a look at how it's built and stuff like that.
You said you're going to make it so you can use the blobs created in Azure within ML.NET?
No, the Azure blobs are different, sorry. Yeah.
Azure and use the model?
Yes, that's right. They will be extending the experience. Yeah. Any
Thank you
other
very much,
questions?
everyone. We'll be here for a few more minutes for any
Yeah,
questions.
thank you.